Welcome to lecture 2, Overview of Embedded Systems. Embedded system definition. Embedded system is a system which is going to be perform only one task with the help of either microprocessor or microcontroller. Any embedded system you can make with the help of the combination of these two, hardware plus software, along with some input and output devices. What are the components required to make an embedded system? I will explain you in the subsequent lecture. In this slide, I just try to tell what is the definition for embedded system. Why this hardware and software is required to make an embedded system? Just to improve the function of the device. How to improve the function of the device? You can, for that device, you can add some computational intelligence. How you can add computational intelligence? Through this hardware plus software. As I told earlier, embedded system you make with the help of microcontroller or microprocessor. I list out a few examples for microcontroller and few examples for microprocessor. Wherever the computational processing power is very less, those places you can pick the microcontroller. Just for control application or just simple application, we require only less processing power. Those places we can use this microcontroller. Wherever the computational or the processing power is very more or high, you require a microprocessor. That application, the video application, audio application, some image processing application, you require the high computational processing power. Those places we can use microprocessor. This is a hardware. This is a piece of software. You can fuse this hardware into the read-only memory. The end user, as a customer, you are unable to change this code. One example, it is an automatic alcohol dispenser. The many people think that all the automatic system is based on an embedded system. It's not true. The embedded system should use microprocessor or microcontroller with some software. Then we can claim that system is an embedded system. This is also a automatic alcohol dispenser. Here we are not using any microprocessor or microcontroller. Just with the help of transistor and some proximity sensor, some DC motor, you powering up this all three, you can make an automatic alcohol dispenser. Rather than knowing about the technical details about the microprocessor, microcontroller and the embedded C programming or some other high-level language programming, you must know about what are the common characteristics of embedded system. There are three common characteristics of embedded system. First one is a single function. It executes single program. Already I told the definition for embedded system is to perform only one task. Okay, either with the help of microprocessor or microcontroller repeatedly. Okay, excuse a single program. It is infinite time. The same program is going to be run until your machine is or device is going to be switched on. The next one is tightly constrained. It must be low power, low cost, small, fast. It with the one word we can say is must be compact. And reactive and real-time system. This continuously react to the changes in the system environment. According to the system environment, the controller has to be react and perform the operation. That is reactive. Real-time system means must compute certain result in real time without any delay. Okay, for some application, for example some home automation or some automatic speed control of fan, those places some delay we can acceptable. In some application, some military application or some the flight landing such type of things and all, you doesn't what is that delay even a single millisecond. Okay, that's why it is a reactive and a real-time system. That is a one common characteristics of embedded systems. Here these are the broad categories and applications of embedded system. I just listed out. Whatever you came across your life in home appliances or some consumer products and some other applications, the many of the gadgets we are using and microprocessor or microcontroller to perform or to improve the function of the device. Design challenges. If you want to make any embedded system, these are the things you must need to consider. Okay, if you want to make one product, what are the challenges? How to optimize it? Okay, how to reduce it? How to mitigate it? Okay, those things we have to consider. The common matrices, first is a unit cost. Unit cost is nothing but that is a monetary cost of manufacturing each copy of the system, excluding NRE cost. That is, for example, if you want to manufacture one washing machine, the prototype is given to the manufacturer. The manufacturer is going to be manufactured. What is the cost they invested for manufacturing the single unit? That cost is what is the unit cost. It not included NRE cost. What is the NRE cost? NRE cost is in the sense the group of R&D people, they can analyze the ground report, what is the consumer requirement, what is the demand among the people, those things and all they can read it out and analyze it. They can sit together and they make the final prototype or the designing of the system. They must spend nearly 3 months or 4 months or 5 months based on the application they took. For that, whatever the cost they spend, that is non-recurring cost. Okay, this is the cost they spend for making one working prototype. Okay, for that how much they are spending, that is the NRE cost. Unit cost, once these people make a one prototype, for manufacturing that particular product, how much they spend, that cost is what is the unit cost. Other than that, size is very important. This must be compact, and the performance, it must be what is that some extent, some application you tolerate some delay. For some application, the execute time and the throughput of the system is very important. And power, it must be a low power consumption. Many of the embedded system product, they are working under battery powered. Okay, so that system has to be not always plugging into the 230 volt and converting into the DC, and you are going to be operate that system if not possible. Okay, sometimes it is a battery power. That's why your system must be operating low power as well as flexibility. They are able to change the functionality of the system without incurring heavy incurring NRE cost. Once you can release the market, release the product in the market, that some flaws in that product, again you can get back into the some R&D people. There may be some slight variation, and again they can relaunch that product. Okay, that flexibility must be there. Once you release the product, it get the overall failure, then there is a huge loss. The company has to be pay more. And the next common matrix is design challenges: time to prototype and time to market. You can see this diagram, you can able to understand very clearly. This is a one product, it is on time. This is another product, some delayed by some 4 weeks or 8 weeks or 12 weeks. If you already told in the ground report what is the demand, what is the customer expectation, you can properly launch it on time, you will get a peak revenue. Okay, suppose you are delayed the same features, the application which that device is going to be performed, you delayed by some weeks, you will get half of the revenue. Okay, half of the revenue only you will get. This is the revenue you will lose, suppose you delayed in some weeks or months. Okay, this is also you can taking care into much, you get the more profit. The next one is the maintainability. Okay, the maintainability is very important. Able to modify the system after its initial release. Once they can release the product into the market, they can able to modify something for some extent, not the 80% or 90%, some 10% or 20% modification. It must be what is that acceptable. That is the maintainability and correctness and safety, and some more things also we can take it into the consideration to make good embedded system product in the market. Thank you.